Out in space, time is not as fixed and universal as it feels in everyday life on Earth. The deeper we look into the universe, the more we discover that time can actually slow down. This strange effect is called time dilation, and it is one of the most fascinating ideas in physics. That means two clocks starting together can later show different times after one travels through space. To understand why, we begin with one rule. Light always moves at the same speed in a vacuum. Because light stays constant, space and time have to bend and adjust in ways that feel impossible. One result is incredible. If you move fast enough, your time actually passes more slowly. Picture two twins, one remaining on Earth while the other leaves on a journey into space. As the spacecraft races faster and faster closer to light speed, time on board begins to slow. Back on Earth, clocks keep moving normally, so more time passes for everyone left behind. When the astronaut finally returns home, they may have aged less than the people who stayed. But speed is only one half of the story because gravity can also change the flow of time. The stronger the gravity around you, the slower time moves compared with places farther away. Einstein explained this by showing that mass bends spacetime itself, not just objects moving through it. A heavy object distorts spacetime like a weight pressing down into a stretched fabric. And the deeper you sit inside that curve, the more slowly your clock will tick. So an astronaut near a massive planet could age a little slower than someone back on Earth. Near a black hole, this effect becomes so powerful that time slows down dramatically. A black hole bends space, bends light, and changes time more extremely than almost anything else. If you placed a clock near a black hole, it could appear to tick almost in slow motion. To someone watching from far away, the spacecraft would seem to move slower and slower. But inside the spacecraft, the astronaut would still feel normal, with time passing as usual. That is what makes relativity so mind-bending. Both perspectives are real in their own frame. This is why movies and science fiction often use black holes to explore huge jumps in time. What sounds unbelievable has actually been measured using atomic clocks with astonishing accuracy. Scientists even account for time dilation in satellites orbiting high above the Earth every day. GPS works only because those satellites constantly correct for changes in time caused by relativity. Without those tiny corrections, your maps, routes, and navigation systems would quickly become inaccurate. Even moving higher above Earth matters because gravity gets weaker and time speeds up slightly. That means astronauts, satellites, airplanes, and even mountaintops experience time a little differently. So space is not just a place where time passes. Space itself helps shape how time flows. The universe is far stranger than common sense suggests, and that is what makes it so beautiful. The faster you move or the closer you are to intense gravity, the more time can slow. So in space, time does not simply pass. Under the right conditions, it truly slows down.